Alright, welcome back. In the last video, we installed IntelliJ and the Java JDK, which will help us kind of code in Java. And basically, you just want to start up IntelliJ and create a new project. So in this video, we're going to be learning about data types, primitive data types, and how to use them, and kind of what they are. So you're going to want to select the Java version, or Java 12, which is the version of it. And if nothing shows up here, you're going to want to go to New and kind of find the Java JDK that we installed in the last video. You're going to want to click Next, go to Create Project from Template, Command Line Up. You can name it whatever you want, but in my case, I'm just going to name it Primitive Data Types. Alright. Oops. Okay. So, I'm just going to delete that. So, primitive data types basically help us kind of store data. That's why they're called data types. So the first data type, or one of the 8 data types that are built into the Java kind of the Java programming language, is the int, which stands for integer. This data type holds holds whole numbers, and it holds kind of a range of numbers. So the minimum, or the maximum, value of the integer can go up to 2 million. I'll just write the number first. 4. So this is the maximum value of the integer, and to read it better, we can put underscores or underscores under to separate the numbers. And the max value would be 2,147,483,647, and the min value, or the minimum value of the integer, is, and the minimum value would just be negative 2,147,483,648. And the integer, kind of like as I said before, allows us to hold whole numbers, and we can manipulate the values of integers by subtracting them or by adding them. So if we wanted to, so int, let's call it number, equals 5, and we can have number 2 be 6, right? And we can have the last, we can have integer. We can print out kind of the sum of these. Sorry. We can put these variables in here, and we can print by clicking the arrow in the top right corner, and we added them, and it's 11. Holding kind of big numbers, or really small numbers, or numbers in general, kind of takes space, right? It allocates space. So basically, to make a program more efficient, or your program more efficient, we can also use other data types, such as the byte, which kind of they have a smaller range of numbers, but they kind of allocate less space, or use less space in a computer when running a program. So the maximum value of a byte is 127, and the minimum byte, or the minimum value of a byte, is negative 128, right? So when you have multiple calculations and they're, they meet the requirements, so basically they fit in between the range of these numbers, it may be a good idea to kind of use the byte instead of an integer, right? And kind of to picture how much smaller the byte is than an integer. The integer can be thought of kind of a width that has like a width of 32, and the byte kind of a width of 8, right? So basically the byte is 4 times smaller than the integer. So if you think of this in terms of a large kind of program, that would make a very significant difference, especially if you're using many integers or many bytes. Next is the short, which the max value of the short value is 32,767, and the minimum short value is negative 32,768, right? So like the byte, the short is also, or allocates less space than the integer, this can be thought of as has a width of 16. So it's basically half the size of the integer, and the byte is half the size of a short. And then also the last data type that kind of support or holds whole numbers is the long. So the max value is, I can't even say this word, so I'm just gonna copy it down, or this number, so I'm just gonna copy it down. So the largest number is now, and let me just write down the last, or the minimum long value is negative. So, and we can see how we have errors, which all we have to do is put an L at the end of each number to specify that this value is a long, right? And the reason why we need to do this is because Java sees this number as an integer, and it automatically says that it's too big since it's out of the range of an integer, and this is called casting. So we can also use lowercase l, but it's kind of makes it a bit confusing. So I'll just use uppercase L. So yeah, and the long takes up more space than the integer, the byte, or the short, which would be, we can see this as a width that as it has a width of 64, right? So it'd be double the integer, 4 times as large as the short, and kind of 8 times as much as the byte. So these are the 4 data types that kind of use only whole numbers. So when you're making whole number calculations, you're gonna want to use these data types. We also have data types that support decimals, which make the number more precise. So, and by the way, these they only support whole numbers, so they do not support numbers with decimals. So data types that do support numbers with decimals are the float. Float value equals 6.0 f, right? And 1.3. So basically the same principle that we're applying the same principle that we did here with the long. This can also be uppercase, but the f is kind of it distinguishes itself from a number you can distinguish it from a number quite easily, so we don't really need to put the uppercase f. But we're also casting, we're also kind of specifying the value that these numbers are, because these values are seen as a double, which we'll see in a bit. So just remember that we need to specify the values of a float. And the second data type that supports data values, or sorry, decimals, is a double, which we can see right. So basically here we don't really need to specify what type of value it is, since Java sees decimals as doubles automatically. If you wanted to, yes, you could kind of specify what these values are, but it's not necessary, right? So if we go ahead and print these, we can see what the difference between these are. So we can print float value, which equals float value. Put double value. Alright, so if we go ahead and print this by clicking the green arrow, we can see a difference between the float value, or the float, and the double. So here the double is more precise than the float, since this only goes up to 8 kind of units of precision, right? While the double goes up to 16. So when we're using decimals, we can use the float or the double. Alright. So there are also other data types that are the CHAR, which stands for character, which we can CHAR value equals, and then we can have this. So we can have, one letter, like a letter. We can have CHAR value 2, which we can also have as a symbol, like an AND symbol, or we can also use CHAR value 3 Unicode. We can also use Unicodes. So if we go down to the let's use the copyright symbol. So we're gonna want to copy this, and we can paste it. Oops. Alright. So if we print these, we can have this is CHAR value plus CHAR value 2 plus CHAR value 3. So then these should all print. There we go. So we can add spaces between to distinguish the different characters, and basically this is what it prints. But if we put 2 characters, it gives us an error because there are too many characters as a value. So basically the character only supports 1 character, right? So we also have the Boolean, which Boolean value, which can either be true or false. So a Boolean can be useful when you want to see if something is if it's kind of true or false. So we would basically use this in a scenario like is Mac, right? So if a computer is a Mac or is running or is something else, right? So if it is a Mac, it would be true, and if it's not, it would return false, and it returned false. So that's it to the Boolean. All right. So these are essentially the 8 data types of Java, or the primitive data types of Java that are built into Java. But there is one more data type, which is called the string, which acts exactly like a as a data type, as a primitive data type. But to call this, we use a capital letter at the start, and as you can see that it is not a reserved kind of word or keyword in the Java language, since it's not part of the primitive data types. So we can also assign a value to this, but in the character primitive data type, we had to put kind of a single quotes, while in the string data type, we need to put double quotes. So what the string does is, or what the string is essentially multiple, or a string of characters. So as we saw before, you cannot put 2 characters in the value or as a value of a char, but in a string we can put multiple characters, so we can type full words. So yeah, the string can also support, or also has the ability to have value to have numbers in it, as well as characters. String value 3. String value 3. So we can also have the AND. But when you are using the string, you can't use these, or this number isn't like a traditional number that you have like this one that we use in the float, or an int, right? Because if we try to kind of add the string value 2 plus I don't know, plus number, which is this one, plus the integer, right? It basically gives us this, which is just this number combined with the other, which was 5, right? So this would be the string value 2, and this would be the number, the integer. So essentially, when you use numbers in a string, or they act as textual data and not as a traditional number, as you can see in the short or byte or integer. So that's basically it for all of the data types. So this video might have been a bit long, but data types are very important, as you will see them in every single Java application that you will write or you will see. So yeah, that's it for this video. In the next video, we'll be looking at variables, and yeah, we're gonna see how we can use them and how you can manipulate them in different ways. So I hope you enjoy this video, and yeah, I'll see you next time.